Good afternoon. This is Dr.T.S.RAVI Kiran, Head of Department of Computer Science, PBC Darda College of Arts and Science, AP India. Today I am going to illustrate about the fourth normal form. So, there are some circumstances where the functional dependencies are not specified explicitly. We need to formulate the functional dependencies from the given table, even though the table is inconsistent, the table is not normalized. In this table, consider the table UCTX. That definitely we can say that the table UCTX is not in normal form. The table UCTX is not normalized because it contains sets. We need to normalize it. Initially, we have a question that whether there is any functional dependencies are invoked in the table, but no functional dependencies are given prior. But even though there are no functional dependencies, we need to formulate it. So we have some constraints to expand the table. The first constraint is a specified course can be taught by the specified teacher by reading all the textbooks. That means that the professor has to read basic mechanics, principles of optics, both the textbooks to teach the physics course. Similarly, Professor Brown has to read basic mechanics, principles of optics to read physics to teach physics course. So both the professors must read the both the textbooks to teach physics textbook. The second constraint is a professor teaching another course may teach other course also. Here, Professor Green is teaching both physics as well as the mathematics. But Professor Green also need to prepare basic mechanics, vector analysis, and trigonometry textbooks. He need to refer basic mechanics, vector analysis, trigonometry to teach mathematics. So these are all the constraints. So with these constraints, I'm expanding the table like that. Physics of Professor Green, basic mechanics, physics of Professor Green, principles of optics, physics Professor Green, basic mechanics, physics Professor Green, principles of optics. Totally, I have uncounted 4 rows. The remaining 3 rows are maths, Professor Green, basic mechanics, maths, Professor Green, vector analysis, maths, Professor Green, trigonometry. Totally, I have uncounted 7 rows after normalizing it. Now, the normalized table is CTX. So, I need to identify the key once it is brought into the standard form. Now, the tables contains the atomic values. Now the table CTX contains atomic values. Suppose if I consider course as key, I have repetitions, physics and mathematics. If I consider teacher as key, green and brown value are repeated. Similarly, if I consider text, basic mechanics is repeated, principles of optics is repeated. Then we need to go for candidate key. Now I'm identifying the key course teacher text as candidate key. Let me check whether the key candidate key is possible with the relation. First of all, physics of Professor Green, basic mechanics. No data is repeated. No row is repeated. Physics Professor Green, principles of optics. No rows are repeated. Physics Professor Brown, basic mechanics. No rows are repeated. Physics Professor Brown, principles of optics. No rows are repeated. Maths Professor Green, basic mechanics. No rows are repeated. Maths Professor Green, vector analysis. No rows are repeated. Maths Professor Green, trigonometry. No rows are repeated. So all the rows are distinct when I am able to form the candidate key by combining course teacher and a text. So we have a question that whether this table is 1.5, 2.5, 3.5 or BCNF. But we can confidently say that this table is in BCN because the determinant is course teacher text and the key is course teacher text. The determinant is course teacher text and the key is course teacher text. Both the determinants and key are the same. We can confidently say that we can definitely say that this CTX is in BCN since the determinant and key are the same. The determinant is course teacher text and the key is course teacher text. Okay. Now the unnormalized table is normalized into BCN. But I'm not saying about functional dependencies. So in order to extract the functional dependencies, definitely we need to go for multi-value dependencies. The multi-value dependencies are the generalized dependencies based on the data of the table. If we have course, then there is a necessity for teacher and text. If we don't have any course, then there is no necessity for teacher and text. So if we have MCA course, then we need teachers and textbooks for that course. Otherwise, the teachers and textbooks are not required. These are all the general thinking. So multi-value dependencies are the general dependencies. If we have MCA course, then the college will recruit teachers. The college will buy textbooks. If we don't have any course, then they don't recruit teachers. They don't buy textbooks. So in that context, we can say that the course determines teacher and course multi determines text. The course multi determines teacher is one multi-value dependencies. The course multi determines teacher is another multi-value dependencies. Okay. From the given relation CTX, now I am able to formulate multi-value dependencies. Now I need to seek for functional dependencies. So definitely I can say that functional dependencies is not possible with the relation CTX. Why? Because I am inferring one theorem. First of all, I am considering two rows from CTX. Physics Professor Green, Basic Mechanics, Physics Professor Green, Principles of Optics. So I am forming two subsets from CTX. The first subset is course teacher, Physics Professor Greeno, Physics Professor Greeno. So the first tuple is equal to second tuple. Physics Professor Green is equal to Physics Professor Green. Now I am inferring one more subset CX from CTX. Teacher text, course text. Thus another subset is course text. So physics to basic mechanics to physics to principles of optics. Here row 1 is not equal to, that is mean tuple 1 is not equal to tuple 2. I am inferring the both subsets CX and CT from CTX, but one rule is applied for CT, the same rule is not applied for CX. In subset CT, tuple 1 is equal to tuple 2. Physics Professor Green is equal to physics Professor Green. But in CX, physics basic mechanics is not equal to physics principles of optics. But both the CTX and CT and CX are inferred from CTX, which is violating condition of FD. So FDs are not possible. Now I am projecting the CTX as course teacher, course teacher. So even though I have so many occurrences, I am writing only occurrence. Physics Professor Green occurred twice. I am writing one. Physics Professor Green occurred twice. I am writing one. Maths Professor Green occurred thrice, but I am considering only one occurrence. Course teacher. But even though we projected, I am unable to identify the key, individual key, either course or text. But I am able to identify the candidate key. Physics green, not repeated. Physics brown, not repeated. Maths green, not repeated. I am able to identify the candidate key, but I am not able to identify the key. So in this context, we can say that the CT doesn't enforces any functional dependencies. But CT is in BCNF because the key is course teacher and the determinant is course teacher. The determinant and key is same. So in that context, I can say that the CT is in BCNF, but it doesn't have any functional dependencies. So the FDs is not possible. Similarly, I'm projecting the table CTX as CX, whereas I'm eliminating duplicate rows, 3 duplicate rows. Independently, we cannot identify key for the attributes course for attributes text. But combining both, we can identify the candidate key. Keys are not possible and candidate keys are possible from CX. Physics basic mechanics, no repetition. Physics principles of optics, no repetition. Maths basic mechanics, no repetition. Maths vector analysis, no repetition. Maths trigonometry, no repetition. So I can able to identify the candidate key from CX. Determinant is course text. Candidate key is course text. Determinant is course text. Candidate key is course text. So I can say that the CX is enforces or ensures BCNF. But functional dependencies is not possible for both relations CX and CT. Even though our project manager asked us to find out the functional dependencies, I am unable to find the functional dependencies, but I can able to identify the multi-value dependencies. So a table is said to be in fourth term if and only if it ensures both FDs and multi-value dependencies. In this case, we are able to identify the multi-value dependencies, but we are not able to identify the functional dependencies. So the table CTX doesn't enforce fourth normal form. In order to enforce the fourth normal form, we have to interpret both multi-value dependencies and functional dependencies. In this case, we can able to identify the multi-value dependencies, but we are failed to infer the FDs. So the relation CTX is not in 4NF. Thank you.